try.
YouTube.
Mhm. Can you check? Hello? Hello, hello.
Yeah.
It's coming? Okay, good.
Can you check?
Good.
Hello. Hello, hello.
I think we can good to go. Good, how are you? Welcome. Welcome. Yes. Hello, everyone. How are you? So today we are going to talk about semantic kernel. Today we are going to do some developments. I will open Visual Studio Code and we'll do some development and we'll see how this semantic kernel will help us. That's the subject of our today's meeting. I hope it's going to take 1.5 hours, maybe 2 hours, it depends. But this subject is much bigger than to squeeze it into 2 hours. That's why I split it into 3 different sessions. So today we will start with the overview part. We will first do the overview section. We will learn the concepts and we will do some quick start samples, how to start using it. Then in the next sessions, coming weeks, we will deep dive and we will go and learn more details about semantic kernel. Is that clear for everyone? Okay, cool. So I'm gonna sit down here and I will talk because microphone is here, so the people in the YouTube will also hear us clearly. So I will sit down and explain it from here. Okay. So first, introduction to semantic kernel. We are going to talk about what semantic kernel is. Semantic kernel is a lightweight open source development kit. It's developed by Microsoft to help us to develop AI agents. Okay, so it automatically integrates with all of the AI models that we have today, like Azure OpenAI, OpenAI, Google Gemini, Facebook, Amazon, whatever we have on the industry, in the community. This SDK will help us to connect those AI services and help us to use them in a single environment, in a single user interface. So you don't need to learn different libraries in order to speak or use different AI services. This SDK helps you to abstract all of those details for you and help you to easily develop your AI powered applications. Okay. It supports 3 languages: C#, Python, and Java. And it's still under development, and some features are is available in C#, but not available in Java or Python. So what you need to do is you need to regularly check the updates of this SDK and update your projects with the new packages, new SDK packages. That's the idea. So it's still under development, still experimenting with new features. And also we know that AI is also improving itself. It's under development. So we are also developing this, and it's open source. It means that you can also contribute from your side. If you trust your development skills, you can clone the repository into your local development environment, and you can write the source code or add your part to the source code of the semantic kernel SDK. Of course, it will be approved by Microsoft. in order to be published. Okay. So, Semantic Kernel is currently used by Microsoft and some of the Fortune 500 companies. They are using it. Why? Because it's modular, it's flexible, it helps you to easily utilize these AI services without worrying about the complexities of the libraries. It also supports some utility features for us. For example, you want to see, you want to audit what's going on in your application in this SDK. So you can integrate a logging framework to this semantic kernel, which will automatically create logs for you. So you can see what this kernel is doing for you at the background, right? So these are some of the features. Currently, it's version 1.0 something, but as I told you, they are improving it. And since it's open source, if we have a new AI services coming, it will be also supported by Semantic Kernel. And of course, this is not the only SDK on the industry. There are other SDKs that you can use it. But Semantic Kernel is developed by Microsoft, and it's for me it's easy to use. I will show it to you.
So it's just compatible with Microsoft products only.
I cannot say that this one is easier than another one, but it's easy. You will
in the market like from Flow, Lang.
Yes.
They have all different.
Honestly, I haven't checked the other libraries. I haven't developed anything with them, so I cannot say that this is easier than another one. But since it's developed by Microsoft, most probably it will get the updates of Azure AI at the first hand before the other libraries.
Now, you mentioned it's open source. That's why I was just curious to understand that, like any third party or something like this, want to integrate their application.
Yeah, they can also develop their own. And don't forget this. Yes.
Organization means like there's not fully Microsoft product that we use. Some of them are using Oracle, some of them are using SQL, different like SAP also, right?
Yeah.
So some of entities use their applications if they want to integrate this good
Yes.
control.
And the good thing is that actually this SDK, it's a dependency injection SDK. Okay, this is the design pattern that is that has been using at the background. Since it's a dependency injection, as developers knows that it's easy to develop a new plugin or new interface to this SDK. Also, you just need to take the interfaces and apply your plugin, inherit your plugin from those interfaces, and then plug and play. It will be ready to use it. Actually, you can see this on this diagram also. As you can see, Semantic Kernel supports plugins. It has a plugin framework because of this dependency injection framework at the background. It supports this latest AI model, and it will be ready for the new models which will be coming in the future. And also it has some hooks and filters which we are going to talk about in our future events. Okay, and your code is here. So this is your enterprise code. Let's say you have a customer service application and you want to integrate this application, or you want to improve this application with AI services. Instead of rebuilding the well, right, you can use the semantic kernel to easily integrate with any AI services and with plugins that you can develop. I'm going to talk about them later also.
This will be end-to-end solution, or just in middleware or something?
This is a middleware.
Okay.
Exactly. This is a middleware between your code and the AI services.
Okay.
But it will make things very easy.
So this will just cover the agentic part.
This will just cover
the agentic part.
Yes.
Okay.
Yes. But it has really nice features, which I'm going to talk about soon. Okay. Hello. Let me introduce Murat. He is also CSA in Microsoft, senior CSA like me. He's also application developer like us, like Sarmat, like me. He's also application developer in Microsoft. Any other question in that slide? Is that clear for everyone? Okay. Yes. So, semantic kernel combines prompts with your existing APIs to perform actions. For example, what I mean from this one, let's say you have an existing APIs in your line of business application. Right? Let's say you are working in a telecom company, right? And you are building a internet application, payment website, right? You go log into the internet application and you want to pay your mobile phone bill. So, of course, these websites have some background APIs, which is already developed and using by the existing website, right? There's a payment API, there is a customer information API, so on, so forth, right? What you can do is you can take this semantic kernel and you can put it as a middleware and you can say that these are my APIs, go and use them for me automatically. And you can build a chat application. When you log into the application, internet web application, a chat window opens and a chat agent start talking with you and said that, let's say, first it will go to the user database and automatically fetch my details from the user database. This is one plugin. And I don't need to develop anything because this API is already there. What I need to do is I need to describe this API to the semantic kernel. And I need to say that this is user API. If you want to fetch a user details, go and use this API. And these are the methods. It automatically marshal the API's methods, marshalling the API methods, and it automatically sends parameters to those API methods to call those methods. So it can go and say, give me the details of Fatih. And those API returns my details. Then semantic kernel take those details and send back to the OpenAI service. And this will be part of my chat history. Then he start asking me, welcome Fatih, how are you? What do you want to do today? And I said that, hello, I want to check my latest bill. I have another plugin, payment plugin, right? Or bill plugin, whatever. It will go to the bill plugin. Again, I don't need to develop bill plugin. It's already there. I just need to introduce it to my semantic kernel. It will go to the bill plugin. It will go and fetch my bill, latest bill. Return back, show me my bill. Then I want to pay it. It will go to the payment API and with the necessary required fields. If there's any missing field, it will ask me. OpenAI ask me, can you write your, I don't know, credit card number or can you fill out these form kind of things, right? And then it will go to the payment SDK API and it will pay it for me. Okay, so it's a middleware which will automatically integrate your line of business application.
But at this moment, we have such kind of facility already in the market. I mean, in a technology point of view, I'm talking about I can build the AI agent instead of using your semantic kernel. So what benefit are you getting?
So this will make things very easy. Yes, you can do it. Technically it's possible, but the problem here is that when you try to do it manually by yourself.
No, I will not do manually. I will create an AI agent for me.
Even the AI agent, if you want to do it with the AI agent, you need to go and do some multiple trips to the AI agent to understand the intent of the user. Okay. Right? And then based on the input, yes, and then understand the intent. Then after you understand intent, you need to find and call the right API.
Okay.
right? So you don't need to do it in the semantic kernel. It's automatic.
So these built-in things are there programmable.
Yes, there are multiple ways.
Who will control this all internal?
It can be automatic by the AI itself, or you can do it manually. There are multiple ways to do it. I'm gonna show them.
Let me ask, when you said the agent, is it creating
talk sharp because we are recording.
Okay, I apologize for this. My question is more about the agents. Are you talking creating the agents using the Copilot or AI Foundry?
No, I mean, I'm talking about purely AI agent.
Yeah, here it's exactly semantic kernel. It allows you, there is another, let's say, advanced topic. It will allow you also to create agents, one or multiple agents that they can collaborate with each other. Now the idea, when he's saying about the plugin, think about it like the function calling does native of the OpenAI. So exactly it's doing the same thing. You will just like empower, let's say, your program, this orchestrator.
You say empower, you mean say you can kind of centralize things.
You make it available. Instead of like the function calling, you will do this URLs. Here is like you just like you use your existing APIs, your existing system, make it available as a plugin. You say just this is the function, this is the URL to calls, this is the parameter expected, and put a description for that. So when you are putting any message, let's say for your agent or program, AI program, automatically will understand the intent, and based on one of the intents, okay, if it needs to call one of these APIs, it will understand, okay, there is a plugin that will help me, and it will go automatically without...
So this plugin from where you will get? We have to feed them?
Yeah, it's an API. He will show you an example how to create a plugin, and you have already a lot of APIs as a part of your system. He will tell you just kind how you will wrap it as a plugin, and you will call it whatever, any API as a part of your system.
Does this method support security?
Of course, security is there.
What do you mean security?
Because there are APIs that they have to...
Authentication.
If your API is expecting a JWT token, or authorization where because if you're doing server-to-server communication, or even client-to-server communication, you need that.
You can do it, but it's not suggested. If you increase the number of the parameters of your API calls, it will consume from your token size.
Yeah, this will be hosted on the client side, or it will be on the server side, because if it is server-to-server side,
Server-to-server.
so that means it is internal.
Because this semantic kernel will run on the server also. It's a middleware. It's running on the server side. And your APIs is also server side. And it's the middleware. So if you try, you can do it. You can send a token. If the APIs that you are calling needs a token, you can send it. It's doable. An API can do it for you automatically. But this is not a best practice.
I think it depends on situation. I mean, what type of agent you are using, you know?
Yeah.
This is like commercial. I think this is not going to be helpful, but if your personal things like appliances or maybe your personal use, it's very helpful. Because I develop a couple of agents for me, like AI agent, for example, for house where, you know, when you asking something to, they will do it for you. They're not for security reasons, there's no nothing, because it's your own. You know? But if you ask like billing system in a bank, if you ask them questions to them, they will not be able to give you answers. You know?
They can do all of these things for you. This is a simple scenario. We didn't want to get deep. They can authenticate even on my behalf. They can get, okay, ask me for OTP, my credentials, all of these things. They can do it. Because at the end, maybe with the example, it will be clear. Okay, it's just API call. You can do as a part of the plugin creation. I want you to authenticate. This is how to authenticate. If something is missing, you can ask it. So all of these things, it's... are there. Sorry, Fatih.
No. Go jump in. Yes, it's okay.
It's a part.
Yeah. So, since we already have those investments, right? We already built our APIs at the background in our line of business applications for the current, for our current environment. So, we will continue to use those investments by using semantic kernel. So you don't need to build anything new in order to connect to or in order to use it inside your AI agents, right? This will help you to utilize your existing APIs and with out-of-box connectors or custom connectors, so you can use your existing investments in your applications, AI-powered applications. Of course, it supports these open AI specifications. That's why it means that you can use also low-code solutions. You can build your low-code applications also with this semantic kernel. Okay. So actually, this Microsoft 365 Copilot, for example, it's using semantic kernel at the background also. So let's do our demo, a quick start demo. So we will understand how it looks like, and then maybe this will answer some of your questions. Okay. So let me switch to development environment. Give a second. Okay. Let me zoom in, make it bigger. So the first thing, we will start from the first step. Okay. First, we will get the packages. These are the NuGet packages that you will download it and add to your project. This is the NuGet packages for C#, Python packages for Python applications, right? And we have also Maven packages for the Java applications. But as I told you, some of those packages still does not support some of the features of the semantic kernel. I will show you a table regarding this one. Okay. First thing first, let me jump into my notes. And first, let me go and open a command line. You can see it, right? Let me do this one. .NET new console. Let me create an application. Okay, so I'm gonna open this one inside the inside here. Let me do this. Okay, this is my project. It's a console application, basic, nothing in it. Let me zoom in. Okay, now the first thing, I need to add the packages to this project. Okay, so I will open the terminal. I'm gonna copy it from here. I'm not going to type. .NET add package, Microsoft Semantic Kernel. This is the first package that I need to add. This one. This one. Okay. The second one is for the logging purposes. .NET add package, Microsoft extension logging. Okay, and the third one is, did I add? No,
There's not come.
logging, yes. Okay, and the last one is console, logging console. So 3 packages. Of course, similar packages is also available for the other languages also, programming languages also. And after you add those packages, of course, you need to add a using statement into your project. So I'm going to remove this and paste it here. Using Microsoft Semantic Kernel and the other necessary packages. Okay. Now, this was the first step. First step is completed. Now we step into the second step, which is add an AI services. So how am I going to do that? I'm gonna create a kernel, but I need the endpoint addresses. I need either Azure OpenAPI URL and key and the deployment name or whatever you are using. It can be OpenAI, it can be Google Gemini, whatever you are using. Okay, so I'm gonna go and copy it from my existing code. I'm not going to type it. Take a lot of time. And after the end of this session, I'm going to delete this API key, of course. Okay. So what I did here, let me close. I have a kernel builder. It's using the factory design pattern here. Okay. And then I will say that Azure OpenAI chat completion. As you may guess, there are other stuff here also. If you click this kernel builder dot, and if you say, look, add OpenAI audio text, add OpenAI chat completion, and there are other plugins that you can automatically, these are out of box connectors that you can use it. You don't need to develop it again and again. Okay. So in my case, I am using Azure OpenAI chat completion endpoint. And this is my deployment name. This is my API key. And this is my endpoint. This HTTP client is optional. You can either give it here or you can create another one outside and you can use that one. At the end, this will do a REST API call to my endpoint. And where is this endpoint? I already deploy it to my Azure OpenAI Foundry. I already deployed this.
So you're not consuming the OpenAI REST, like that you are directly. You are consuming it through Azure.
No, Azure also has its own OpenAI endpoint. Azure OpenAI. I am using that one. So this is my OpenAI, Azure OpenAI endpoint, or you can go to the AI Foundry and you can see it from there. Okay. So we already showed how to deploy those models in our previous sessions. So you can go and check our YouTube channel to watch them. Okay. So yes, so here, as you can see, if I go to the deployments, you can see these are the models which I already deployed previously. So I am using this GPT-4o right now. Okay. Clear? Good. Now, what I did is I defined my deployment details. This is my those are the deployment details, and I said that kernel builder dot build. Okay, that's the one of the way that you can create the kernel. There are multiple ways. I will show them in next slides also. Okay. What else? Or for example, you can use this one also. Another way. Let me do this one. Let me comment this. and I'm going to use another one. Host create application builder, builder service at Azure AI completion, details. Then we will create the kernel inside this builder services. We are adding it as a service. Okay, that's another way that you can use it.
This one also uses factory design.
Exactly. What is missing here? Maybe we need to include some libraries using except hosting. Okay, that's another way. Now, there's one important point at transient here. There are different way of adding those services. Transient means that every time when I try to use the kernel, it will create a new instance. Okay, this is the first one. Whenever I try to use kernel, it will create a new instance at the background. Don't forget, this kernel object is a very lightweight object. It's just a middleware. So it will not add an extra load on your application. So don't worry about the memory usage of this kernel. Okay, you can create it transient. Yes. So for every session, it will create a new instance. Another way of this add transient is add singleton. You can also create it as a singleton. It's not showing it here, but it's also another way. There was another way, but I forgot that one. Okay, but for this object, kernel object, it's okay to use this transient version. Okay. So that's another way that you can create. Let me go back to slides. We create the AI services. Now we are going to use these enterprise components, like, for example, logging. I want to see what is going on at the background when this semantic kernel is working, because this kernel will automatically go and talk my background services, plugins, and I need to understand, I need to see what it is doing at the background, right? And if there is a problem, I need to understand this. Why it's not going to payment plugin, for example. I need to improve it. So you need a logging mechanism. So it's also out of box. So you need to add this logging services. As I told you, this is out of box again. So if I switch back to my code, I will add those logging services to my code. Let me find this one. Okay, this one. Add enterprise components, builder, services, add logging. And then I will give this at console, and the level of the logging is trace level. It can be trace level, it can be debug level, it can be critical, whatever. It depends on the level of the logging that you want to log, right? So if you change this one, maybe debug another one. So you need to check, you need to, of course, read the documentation about this library.
Hello.
Hello, welcome. Come. Can you move some of those chairs to that side? There is one more here. You can use that one. Yeah. Let me simplify this part also for all of us. This is much easier to understand. Populate the OpenAI deployment, create the kernel with these parameters, and add enterprise components. Okay, now let's go back to here. This is also done. Enterprise components also done. We add a login. Now it's time to build my kernel. So I will switch back to code and I will build my kernel. Okay, kernel builder.build chat completion service get required service I chat completion service. Okay, now after I create this one, this is unused, we're gonna remove it. That's also done. Is that clear? Okay, now this is also done. I built the kernel. Tick. Now semantic kernel also supports different memory storage, vectorial memory storage. It can be a database, it can be a vector database, it can be cache, whatever. But this is not object of our today's session. That's why I'm gonna skip that one. But if you want to learn, you can go and check documentation. There are also out-of-box vector storage libraries that you can automatically integrate your semantic kernel with those databases. Okay, or you can build your own. So, but now this is another day's subject. I'm going to skip that part. Okay. Now let's add our plugins. Okay, I'm going to add my plugins. What was the, let's say I will come here and I'm going to create a new class. And I will say lights. Is it correct pronunciation? Plugin. .cs. It's a new class. So this plugin will go and switch on and off the lights for me. And it will also give me another method which will give the latest status of the lights. Which one is on, which one is off, which room is on, which room is off. And then I can integrate this API with a IoT tool which will automatically switch on and off the lights at my home. Okay, so I will go to the light plugin and I will create a class which is called light model. This is my light model. Okay, and it has JSON properties, system text JSON serialization. Okay, this is my light model. Then I will create a class called, which use this light model, public class lights plugin. My first method is mocking the data of the lights. So when I ask the light plugins the status of the lights, it will give me this list, light model list. Okay, it's light model. Light model is here, and it has different light models. The first one is table light, which is switched off. The second one switched off. The third one is switched on. It's just a mock data. Normally, I need to go and read this data from my IoT device if they are on or off, right? But this is just for mocking purposes. Then I need to create an API, which I will call get lights async. Give me the status of the lights. As you can see, it returns the list of the lights to me. That's very basic API. It just returns the lights, status of the lights. But I need to introduce this API endpoint to my kernel, because my kernel cannot know how to call this method. I need to explain it. What is this method for? In which situation my kernel needs to call this? He needs to know this. Otherwise, he cannot call it. Right? How am I going to do it? With some of the attributes. We call them kernel functions. So I will go and add those as an attribute. Of course, I need to add some using statements here. Kernel function, the name of the method, get lights. Description, get the list of the lights and their current state. And return, this is the description of return statement. So we are explaining, introducing this method to my OpenAI. Okay, what am I returning? An array of lights. Is that clear?
So this is kind of your system prompt.
Yes, yes. And what you can do is, that's a good point actually, you can also take a prompt and you can create a plugin from a prompt. You can do that. This library also supports this. Or you can use this Promptify files, workflow files, and you can use them also. It's also supported. It's because at the background, it automatically serializes this class as a JSON file. And as you can, if you remember, this Promptify files is also JSON files. Same thing. Okay. Now, what else? And I want another method which will change the state of the light. So this method will take the light ID, and if it is on, make it off. If it is off, switch on. Right? So that's why I take an ID and I take is on Boolean or off. Okay? And of course, I need to do again, introduce this to my OpenAI. Change state, change the state of the light. The updated state of the light will return null if the light does not exist. Clear? Any question? Good. Save it. Now return back to my program. My plugin is ready. One important note here. Normally, there is a convention base of creating plugins. Normally, we need to create a plugin folders. And inside these plugin folders, you can create different folders for plugins. And you can define your plugins by using a JSON file and a code file. But this is a different, again, subject of another session. This is a simple way of creating plugin. As I told you, there are different ways of creating plugin. This is the simplest way. Okay. Now, I need to go to program CS and I need to tell that use this plugin. How am I going to do that? Add plugin. Kernel plugins add from type light plugin lights. This is the name of my plugin. Okay. Represent text. Question? Clear, right? Okay. Save it. This is also done. Add plugins, done. Create kernel function argument. I'm going to skip that one. Create prompts. We're going to talk to prompts and templates later. I'm going to skip that one also. Now, planning part. We're going to do a planning part. So what am I going to do is, I will copy this one, the planning part. I will say that OpenAI prompt execution settings. This is a new object. And I'm going to say that function choice behavior is auto. This is the question that you asked. So when you choose auto, it will automatically find to which method it will call by using those descriptions on behalf of you.
So there are multiple functions.
Yes, there are, yes. So it will automatically, as I told you, these plugins are serialized as a JSON. You can have multiple plugins. Payment, get user data, get the bill, right? Or think about a health sector, right? Get the patient information, previous visits, laboratory tests, results, whatever, different APIs. So you need to introduce those APIs to the semantic kernel and explain it. Which API is for which? So semantic kernel automatically find those APIs and call the necessary endpoint on behalf of me. Okay. That's another best practice. It's like a prompting. It's about prompt engineering. If you explain it details, as much detail as you can, it will be work much better. Give me a second. Pizza arrived. Hello? Okay, in front of the door? Okay, coming. Okay. Let me call Sarmat. Sarmat, my friend, Talabat arrived. Can you go and pick up for it for me? Thank you. Let me send his phone. Sarmat. Yeah, done. I will give his phone number to you also, WhatsApp, so you can call him. I sent. Thank you. Okay. Now, yes, we said that auto, but there are also other ways to call them. For example, none. Also, there's a manual way to call it. You can choose manual. It's not showing here, but there's also manual way. There are different ways to trigger those methods. Okay.
I think you can call functional dependencies as well.
I can call
dependencies.
Dependencies. Yeah. What kind of dependencies?
For example, if you're talking about the billing, okay? So if
yes, for example, yeah, but you need to explain it to the OpenAI.
Yeah.
Again.
Okay, OpenAI when it's training, you will get your data, data set, right?
It can do multiple trips.
Okay.
We will talk about them later on. So your semantic kernel go to the, for example, first API, get the result. If he needs more data, he can go and call another API.
Sometimes you ask for auto if you get any.
Yes, it can do it. Yeah.
Schedule.
Yes.
If I ask previous year for the particular date, so how will I calculate? So if there is dependency,
yes.
So he can define on
yes.
That way again. So
yes.
you have to go wait for that. Then it will
yes. That, yes. Yes. It can do that. Yeah.
Actually, you have to do the practical with that.
Yes, of course. Yeah, I can.
Yeah.
Now, that's also done. Switch back to here. Planning is also done. Now we need to invoke it. Right?
So all 1 to 10. What is the topmost critical stage for you? You have to train your
planning, I guess. Right? Plugins. Plugin also important.
No problem.
Yeah, the planning. Plugins needs to be descriptive. If you want your application to work properly, your description of the plugins needs to be clear enough for OpenAI to call. It's like prompt engineering. That's why tracing is also important. If you feel that it's not working correctly, you need to trace it and you need to find what's the problem in the flow. Maybe you need to add some extra description to some of your API methods to help OpenAI to understand what is it for. And also, this you need to think about the security point of view also. You need to clearly explain what are those methods for, so that those methods shouldn't be called with this vulnerable calls, right? So now I need to go and call this one with this is a long one. I need a history. History is also out of box. Why I need a history? Because I need a context. Actually, OpenAI needs a context, right? It's a chat. So because of the chat, he needs to keep this context at the history so he can reply accordingly, right? That's why I need a history object here. Then user input, it's the variable that I keep as a user input. Then I will do a do while loop. I will ask the console to user enter the input. I automatically add this user input to the history. Then I will call my API. Okay? Kernel. With this semantic kernel. With history. With those settings. Which settings are they? These settings. Okay? And then this is my kernel. Then assistant will reply back to me with a result. So I add those results to my history also. With the role and the content. If it is not empty, I will write it. If it is empty, write empty. Then console read line. Or if it is exit, it will exit. Now, is it clear?
Yeah.
Okay. So now I will say .NET. I need to save it. Yes. I forgot to save it. One more time. Yes. Now here is the user. Let's see if it is going to work or not. So you see these are the traces, which is automatically trace the console. Okay, you can write those traces into the database also if you have a logging database. So what is it happening? Semantic kernel, chat completion service. This is text context, hello. And then again, it goes to Azure OpenAI. And then lights get, check the other methods, how many tokens it consumes. You can see all of them. How can I assist you? Can you tell me the status of the lights at my home? Now you see it do some multiple steps at the background. So it will go to the connectors, right? Then it will go to the semantic function, get lights invoking. It will get the status of my lights, right? With the arguments, so on. You see this is the returns from the get lights. And then it will return, it says that completed, this is the duration. And then it will say that this is the token that you use. Sure, here's the current status of the lights at your home. Table lamp off, porch light off, chandelier on. So I want to say that, can you switch on all of them with my beautiful English? And now all of them is on. Okay.
So you give the status for all of them automatically.
Yes. And it automatically do the current API calling for me at the background. So it will make things much easier. Think about the line of business applications which you already developed. If you convert them with as a kernel plugin, right, with enough description, you can easily call them from a chat agent.
But how do you expose this? Like, for example, if I want to put this on my website, and if I want to use it as a RAG application, so how do I use this with the front end for RAG?
You need to develop a front end and call these methods from this front end again. Of course. Of course, yes. There are some frameworks. For example, I believe in the Python, for example, there's a framework called Streamlit. I don't know if you check this one. Streamlit has they already have a built-in user interface for those chats window, for example. You can take and use it. And if you check the Microsoft samples, I believe that you can easily find a user interface which you can adapt it in your projects.
For the in case of a legacy application, it would be tough, right? Because the code would be old. It might be not as much descriptive.
For which kind of application?
Any legacy line of business.
Yeah, then you need to modernize them. Yeah, you need to change them. Or maybe you need to write another middleware intermediate API between your legacy application. Yes, wrapper. Or maybe you can use an API manager, APIM.
Okay.
Maybe you can add those. Maybe. Yeah, I'm not sure about that one. You need to try.
Another question.
Go ahead.
I mean, in the APIs, how creative can the model really get? If you ask it, for example, to turn off one of the lights or to retrieve, for example, one of the lights, which one is off? Can it do something outside the scope of the defined APIs, but using like the API itself, but not in the scope that we define them?
No, I didn't understand this.
Let's say we have a couple of APIs, they're generic.
Generic.
Generic
Okay.
APIs, they do generic things. What if we ask it to do something specific using those generic APIs? For example, if one of the APIs like turn off one of the lights, turn off a light. What if we ask it to turn off the table light and the chandelier light? Can it do it, or does it have to like two calls each one is like turn off the table light, turn off the chandelier light?
I believe it can handle.
Yeah,
it can handle it. We can try it.
But
So, for example, turn off table and porch lights on. Okay. But it will do multiple steps, multiple trips. Can do it.
It gives a little bit of pretty good right code. So
Yes, yes. As I told you, this description part is crucial here. You need to explain it, and also the parameter names, descriptions, how did you describe,
you get the
and you need to define the limitations also, to not to abuse it. That's why tracing is also important.
So the security is on us, not
It's always on us.
And that's what I said initially, that it's your own device. I mean, you have your own device, you can use it. Otherwise, from the business point of view, it's really very unsecure.
No, but I guess like if they are providing this kind of food, they definitely going to providing a rate limiting as well, right? So number of calls that can be done in a minute.
Yeah, you should.
That technology gives you the rate limiting.
You have these token limits.
Yeah, tokenizer is the most important.
Can you do like a line graph where you limit the amount of inputs you get?
One more time. In which state? Yani the limit amount of the user input?
Yeah.
You can do it from your code. Because you are the one who is reading it from the console, right? Or web interface. Use some of the libraries which will. Or what you can do is, another suggestion, you can call multiple OpenAI calls. The first one will go and summarize this input. get the main subject, and the second call will do the job, for example. If it is too long, call the first one, do a summarization, and then call the second one, for example. So you need to add your own logic also.
Even calling the first one is a whole.
Yes. Yes.
We can summarize it into different steps. Yani, call it multiple lines, get multiple summaries from whatever this guy has coming to you, and then you can stop it.
I mean, we're trying to minimize
The calls and also this
we
is
are
about
doing a call to minimize the call. Minimize the call.
Yeah, this is up to your workflow. Yeah, logic. Yeah. Some of the companies, they don't want to limit. It's up to you. If it's an internal application, right? Internet application. Yeah. If you want to limit, you can use the front end also to limit. If it is greater, if it is longer than 500 characters, stop. He cannot write it, for example. You can do this kind of rules, business rules. Okay. Cool. Let me continue. Okay, because there are still slides that we need to finish. Yes, as I told you, Semantic Kernel supports 3 languages, C#, Python, and Java as of now. And they are still developing it. Okay. These are some of the core capabilities in the SDK. As you can see, each language supports most of the features in Semantic Kernel. Currently, this Java, for example, does not support open telemetry logs right now, but other features are already there. So prompts, native function plugins, open API, automatic function calling, hooks, and filters. Those are the supported features. Okay.
Do they have any plan for TypeScript?
I don't know.
Yeah,
But
it's surprising to see JavaScript not listed.
I don't know.
Chain language, after all of them, they're going in TypeScript, and like it's gonna be now most widely used.
Yeah, we can check this one, or you can check this from their GitHub repositories. Everything is on the GitHub repositories. They have a GitHub repository. So prompt template formats. We will talk about this prompt template formats later on, but you can see which language supports which prompt template formats. So this semantic kernel provides a variety of template languages. These are the different languages actually that allow you to embed variables and invoke functions with a different ways, from different ways. So we will have some samples about handlebars and liquids in the future events, but you can see which language supports which prompting templates. Okay. Prompt serialization formats, YAML and Promptify. As you can see in C#, it supports Promptify also. You remember I explained the Promptify before in one of our previous sessions. It supports this Promptify workflows also. You can use that one. Okay. What else? AI service modalities. As you can see, text generation, chat completion, text embedding. This is experimental right now. Text to image. It automatically uses DAL-E at the background, so you can integrate it into your projects. Image to text, supported by C#, so you can ask a user to upload an image to your line of business application, and you can send it to image to text endpoint. It will check this image and generate a text for you. For example, you can ask a user to upload a bill. It's a line of business application, and you want your employees to upload their bills so you can do the payments. Expense, they will expense it, right? Or you are an insurance company, you want your users to upload the doctor prescriptions, reports, forms. They can upload it as an image, so you can send it to this image to text, automatically analyze the image, give you a summary, so you can put it into your database, for example. Right? Text to audio and audio to text. This one is, for example, we are using it for one of our customers in Qatar. We integrate it with their HR database, so they can click the microphone and they can talk. How many remaining vacation days do I have? It will automatically listen, convert it to text, and send it to the OpenAI. And doing some rec, go to the HR database, fetch the data, and return back. Okay. Connectors. These are some of the AI service connectors out of box that you can automatically connect within your application. For example, Amazon Bedrock, Anthropic, Azure AI, Azure OpenAI, Google, Hugging Face, Mistral, Olama, Onyx, OpenAI, other endpoints. These are all supported. You don't need to build anything. You just need to define which OpenAI endpoint you're going to use. That's it.
What about the tools then? For example, if I want the capability of doing research, like what if I hook a browser tool or Wikipedia, or like normally the kind of SDKs they provide you tools.
Yes, you can do it with the hooks. Yes, you can do it. With the plugins and hooks, you can do that. Yeah.
So they are present?
Yes, some of them.
Yeah, not of course.
Yeah, not, there are some out-of-box ones. We will talk about them later also. Yeah. Any questions so far? Is everything clear? Okay, I assume this silence as yes. Continue. Okay, now let's dive into the details of the kernel. This is what is going on at the background. We have a kernel in the middle. Okay, this is the semantic kernel, the full picture. And in the center of the semantic kernel, we have a kernel. As told you, this kernel is a dependency injection framework. So you can inject these plugins and other hooks, libraries into this kernel. Okay. In the one side, we have application. On the other side, we have models. It's a middleware. It will get the input from your line of business application. It will select the right AI services. It will render the prompt for us and then invoke the right AI services at the background. Then it will get the responses from the AI services, create a function result. Maybe it can go and call another function on behalf of us. Maybe it will do some RAG at the background for me, and then it will return a meaningful response back to me. Okay? And it will also support event notifications.
So basically that comes to the user prompt.
Yes. Yes. What are those services? Before building a kernel, you should first understand two types of components in kernel. The first one is the services. The second one is the plugins. Services, these are the AI services which I showed you, right? For example, chat completion services. For example, logging, enterprise services, or HTTP calls. These are the services which is necessary to run your application, right? Plugins, these are the components that are used by your AI services and prompt templates to perform the work on behalf of you, right? We already talked about them. Retrieve the data from the database. HR database, so on and so forth, right? So how am I going to do that? First of all, I need to import the packages. Then I need to add these services again. Builder, add Azure OpenAI chat completion, right? With the model ID endpoint, and then logging, and then plugins. I already explained this, right? Then or the second way, this one is the easy way, easy to understand. There's also a second way, which is dependency injection. This one is a little bit complex than the previous one, but it's up to your developer which one they want to use it. But they are doing both of them is doing the same thing actually, right? Here, we will create a builder, then give the details of my OpenAI endpoints, adding OpenAI chat completion service, then create singletons of your plugins. Why? Because those plugins is static. I don't need to create a new instance every time I call it. That's why plugins needs to be created as a singleton, which means that it will have a single instance running at the background for each user. Okay? It will have a single instance and it will not consume lots of memory at the background. Then we have a light plugin, speaker plugin, then creating a plugin collection. Again, this is my plugin collection. This is also singleton. Then finally create the kernel. This one, transient. As I told you, we recommend to create kernel as a transient service, so it is disposable at the end of each request. But as I told you, it's very lightweight. You don't need to worry about the memory usage of this kernel object. It will not be a performance concern for you. Okay. For Python, same logic. You need to import the Python packages, then create the kernel, then you need to add the services. These are the endpoint and then plugins. I am not a Python guy. So for the Python guys, this is how you do it in the Python. For C# guys, like me, old guys, we use the C#. For older guys, Java. I don't know, how old are you?
From the enterprise edition.
Okay, let's say for the enterprise edition, Java. Let's say bank developers, right? Bank developers, Java. Telecom developers, Java. Or mainframe developers, Java. Any questions so far? Is it clear? Cool. The third concept in this today's session is components of the semantic kernel. It's a long subject. I'm not going to explain all of them. I'm going to just mention first of it, okay, which is AI service connectors. Okay, what are those? So as I told you, this one of the main feature of the semantic kernel is its ability to add different AI services to the kernel without a complex development, without need a complex development. It supports different services out of box: text generation, chat completion, text embedding, image to text, text to image, so on and so forth. So these are out of box. For C#, it's already there. For Python, only the missing part is this, but I believe soon it's going to be also ready. For Java, they need to wait a little bit more. But as I told you, you need to follow their GitHub repositories for the latest updates. And they are building new packages every day. It's there. So let's do a quick demo with the chat completion. Okay. So I will go back to here and Again, I'm gonna copy some stuff here. Let's do it. Okay. .NET new console -o chat completion sample for events. CD chat completion sample for events. Let me close this one and cut. And this is my. So the same idea. What I need to do is I need to first add the necessary packages to my project. Then I need to call this chat completion service. So the first thing is first. Let me go back and copy it from here. First of all, I need to say .NET add package Microsoft Semantic Kernel. Okay, semantic kernel is here. So I'm gonna add the using statements. Let me zoom in. Too much. Yes, much better. And then I will add my kernel builder. Okay. Then I will add my chat completion service. And then chat history. Right. Then let's say add a message. What do you suggest for drink? Okay, and then I will check and do this one. Response, chat completion service, get chat message, async. So there is two kind of calling this one. One of them is non-streaming, another one is streaming. This one is non-streaming one. What is the non-streaming means that it's calling it, goes to the LLM, OpenAI service, wait response to complete, and then return back to me. This is non-streaming. It waits. The thread is waiting to AI service to return back to you. Okay, so it will show the result in one time as a whole chunk. The second way is a streaming. Sorry? It's without waiting, exactly. Chunk by chunk. This is the streaming one. So this is the streaming one. Let me copy that one also. And this is the streaming one. Control K, Control U. And let me comment this one. Okay, this is the streaming one. History, I need to remove this one. Actually, remove this one also. Hello, how are you? Response. You see the differences here? Get streaming chat message content async. This is the difference. This is get chat message. And then await for each chunk in response and console write chunk. Of course, you need to translate it to Python.
So the problem is not in the render. I can use it.
Okay.
I still can understand it.
Okay.
But the thing is, I'm not really getting the objective of doing this.
This is I'm just trying to show you how to call this chat completion service. It's an out-of-box service with semantic kernel.
So what's history
For now, nothing. For now, nothing.
First message that when you run this,
Mm.
so I know how you, this is the very first message is going to give you with or what?
Yeah, it will give me an answer. So we can try.
What's the final
Let's.
outcome?
It will answer me. I am good.
So this time you're not asking the LLM to respond to you. This is the very first message that you're going to get.
No, it will go to the LLM.
You know,
This is element. That's
so
what
instead of user message, you provided a hardcoded message.
No, this is a user message. You see, this is a user message here.
And I mean the input. Like previously you controlled, you input.
Yes, I just for the sake of the simplicity, I write it as a user message. I don't want to type in this sample. Normally, you need to type the user message in this for the sake of the simplicity, and I want to save the time. That's why I directly put the user message in the code. Yes, I don't want to. Yes, I don't want to spend time to type it here. Okay. Okay. So let me save this one. Open the terminal. .NET build. Let's see. Okay. .NET run. Cross the fingers. Hello, I am just a program, so I don't have feelings, but I'm here and ready to help you. How can I assist you today? Okay, it goes to LLM. But
yeah, it's going to OpenAI.
yes.
So what about the non-stream?
Non-streaming. Let me close this. It's working in the terminal. Yeah, you can run it from the terminal also. Let me close this one, take it to up, and open this part. And of course, I need to write console right line response. Okay.
The way to follow-up messages.
Follow up give me a detail.
For example, you said hi, right?
Hmm.
It responded to you, hi, how are you? Then you can have word. So then another question.
Yes, that's why I need a chat history. This is how I keep the history of the conversation between the user and AI assistant.
Actually, here just we are feeding AI. Give the
So this is the non-streaming version. Since it's a, sorry?
What's the difference in the
You cannot understand the difference here because it's a very small response. It's just a kilobyte. You cannot see the streaming. But think about if it's an image, a big image. It will, if you use the streaming one, the image will be loaded like some part will be loaded first and the rest of the image will download. It depends which framework you are using. Of course, you need your front-end framework needs to support this, how to show this image. Again, or if it's a big text, think about the ChatGPT. When you ask a long question, it will answer you a long text and it is streaming. The scroll bar will come and then it will scroll down. This is streaming. But in this case, since the answer is too small, it will give me a long question. You can see the streaming maybe.
You want to stream, I want to first do like a yield and then you should yield.
No, in that case, yeah, this is not streaming one. If this is the streaming one, which I am doing await for each, you see, for each statement, it will go and do a for each statement. Whenever it receives the response, it will print it to the screen. if you ask a question which a long answer, which has a long answer, I can demonstrate the streaming part. Do you have a question which has a long answer?
Something like the word application. Tell me the history of marketing.
Yeah. Okay, let's do it. Essay, ESSS? Right. Essay. Okay. Let's try. Save. Did I save it? Yes. You see, it's streaming now. You got it, right? If I do non-streaming, I need to wait maybe 5 minutes. It will load everything and then flush it in one time. Good.
Can this be used with the local portfolio?
What do you mean localhost? Yeah, it supports these OpenAI endpoints. Yes, you can. If it is available as a, if you can call it, yes, you can.
Think of it as just an orchestrator, right? So it's more about managing all these different components. The LLM part, you just plug it into OpenAI, Llama, and anything.
Tamam. Okay. Good. Now, this is also done. What else? Yes, chat history. Chat history object is used to maintain the record of the messages in a chat session. We are using this one to store the messages from the different authors. It can be a user, it can be an assistant, it can be a system or tool. Okay. With this chat history, you will define the conversation details or the scope of the conversation for your users. So, as I told you, there are different roles in chat history. The first role is the user role. It is equivalent to the queries made by user. This is you. User role is you. Okay. The second role is assistant role. Assistant are the model's responses based on the user messages, the responses from the LLMs. Okay. The third role is development role, developer role, or system role. We are in Microsoft, in Azure OpenAI, we are calling this one system role. Is that still system role, right? But if you go to OpenAI, you will see that they rename it as a developer role. So developer role, the previous name of the developer role is system role. And we are using this system role to allow you to specify the way the model answers the question. So for example, you will say that as an assistant, you are a helpful assistant, helpful health assistant. You define the borders, or you are a librarian, kind of, or you are a helpful assistant, or you are a car dealer, whatever, right? So you define the role of the system. They call it developer or system role. And the fourth one is an interesting one, which is tool role to simulate the function calls. What's that meaning? You know, these AI systems are very selective nowadays because of this responsive, what they called it? Responsive AI or responsible AI. So for example, if you want to give user details, health details in the system message or developer role, this background AI services might discard those details automatically because of the privacy. Okay, they automatically discard it because this is against the privacy of the user. So you cannot give the user detail as a system role. That's why you need to use a different role.
This is one of the conditions in the chat with OpenAI, paid and unpaid. We use unpaid, there is no guarantee we keep the data for paid one, they have done.
Okay. So this is why we need a tool role. It will simulate a function call. For example, a user came to your system, log into your system, and you need to fetch his data in order to answer his questions. You need to fetch his HR data. You need to fetch his health reports, previous health reports, in order to answer his questions, right? So in that case, you will use this tool role. This tool role will automatically go and search the health database and fetch the health record of that user and put it into the history, chat history. So when user asks, what is my latest blood pressure and give me some suggestions, which medicine should I use? It will go to the previous blood pressure records, check his history, and give some details, give some suggestions.
So this tool is directly interacting with the database, or again,
you are developing it.
And so it will be okay.
Yeah, it's a plugins. You can develop it.
It's a function that you define.
Yeah.
So is this only for
Yes. But if you want, so you are calling something at the background. Actually, AI calling it, and you need to put it into the chat history. How are you gonna put it? Which role you're gonna use it? The tool role you're gonna use it.
I mean, these roles are defining the chat history
Exactly.
or the chat history for the semantic kernel.
It's general. You can use it as a general also. So here's how to create a chat history. You already saw it. Chat history object, right? And then, so for example, here, add a system message. You are a helpful assistant. Define the role of your assistant, right? Then add user message. What's the available order? Or you can ask user to type this message in the user interface, and you add it to the chat history at the background with your code. Then assistant message is the message that will return from the LLM model. And then again, add a user message. I would like to have first option, please. So you define a conversation at the background in your code. So you can resume the chat from here. This is the how you called it? I forgot the name. Anyway, this is the context of the of my chat. Then you can take the rest of it. So of course you can, but the system message is important. You need to define the role of this AI model. You need to define the borders. Otherwise, the users. What was the name of what they called it? How they hacked the prompt? What? Not hallucinate.
Prompt injection.
Prompt injection. They will do a prompt injection. If you yes, or jailbreaking. Yes, if you don't define the borders, guardrails of the your AI agent. Exactly. Yes. Now, so we already explained this one. So what we can do is actually, for example, this is the semantic kernel, right? So I can take the same one here. Let me do this. For example, this is my history. Then I will take this one. Right? You are a helpful assistant. What's on the menu today? We have pizza, pasta, salad. I would like the first option, please. This is the context. Then I want to say what do you suggest for the drink? Or again, you can ask the user to write it onto the console. But for the sake of the demo, I'm just writing it here, right, to save the time. Okay. And then I built my history with that way. So I define the context. So if I run this one, .NET run, so it will automatically take everything from the history. And then what, okay, great choice pizza. For drink, I suggest classic pairing like soda, sparkling water, blah, blah, blah. Red wine, estağfurullah, haram, haram. And so on. Okay?
You need to put in the context if you're a halal restaurant.
Halal restaurants, don't give me alcoholic drinks. Yes, you can do it. Yeah?
They're not in Dubai, they're in Qatar.
Or you can say that in the menu, I have only those drinks, suggest something, these halal drinks. Okay? That's how it works. Good. So, adding a richer messages to chat history. For example, what's going on here is that, let me take my pointer. This is system role. You are a helpful assistant. This is another way to adding it in C#. Then this is user role, one of the username. And this is the text context. This is the image context. You can also add image to the history, right? And then this is assistant role. We have pizza, pasta. And this is user role. First option, the same code, but longer with a different syntax. Okay. Tool role. This is important. How do we simulate the tools? Again, chat history, assistant role, and we are doing a function call context. And function name is get user allergies. Plugin name is user. ID is 1. And arguments, username and the value of the username. So, the second user, his allergies, his username and ID 2, and his username. What I told you about this user tool role, we are simulating the function calls. Okay, so these are my functions. Again, I am simulating it. Function result context, get user allergies. This is the name of my method. You see, get user allergies. I am calling this method. Get user allergies. User, for which user? User 1. And this is the allergies of user 1. This is the allergies for the user 2. We are just simulating a function call. But normally, so you are building the chat history, right? But what you can do is, you can build your own plugin and you can do these function calls by calling those plugins. And you can take the answers and include it into the chat history. But again, the aim of this code is to just show you how these function calls are simulating. So the above this first 1, 2 function call content will call those 2 function. And ID is required. That's how the semantic kernel knows which function call to call which function. It's required. 001, 002. If you didn't give them, it will fail.
So, in the background of the
This is in the background. I am simulating, as a developer, I am simulating plugin calls in the chat history with my code. Normally, you will call the OpenAI to call the plugins on behalf of you. Yes, this is just a training purposes. Yes, yeah, and to show you the training purposes to train you. Yeah, you can use, but this is normally in a line of business application, you wouldn't use this method. You will call a real plugin.
You'll collect a proper knowledge base against it, yeah?
Exactly. In a real application, you wouldn't do this. You will do a proper database to fetch the allergies of your patients. And you can also inspect the chat history. This is the aim of this inspecting the chat history. For example, we have this chat history object, right? And then we can count the history details, how many messages in the history. Then I can get the results, new results from the LLM. Then I want to print the last message to the console. That's why I am using the current chat history length, the previous length, and then chat history count. It's smaller than chat history count plus plus. It's like for each statement. So I have a history and I get new message. So, and then I'm creating a for each statement. Let's say I have a 5 message in the history. Starts from 5. The new length is 6. Return once and print this new message. If I have a second message from LLM, this will return 2 times and print these messages. So why I am showing this one, what's the aim of this code? Again, the semantic kernel automatically go and call the plugins for you. And it will automatically include some messages in the history. If you want to know what's the context, you can go to the chat history and you can learn the context as a developer. Let's say you want to log them to the database. That's how you can go and fetch the history from the chat history object. You got the idea, right? Because the semantic kernel will do some stuff at the background automatically.
Don't we get this already from the first option?
You can, but let's say you want to keep it.
So,
Yeah, some other reason, right? That's how you can do it. Any question? Cool. Now, another important subject in semantic kernel is function calling. But we are all tired. That's why I will leave this function calling to next week. Okay? I don't want you to hate me. That's why I'm just stopping here. Let's go and eat pizza. And then we'll continue next week. Inshallah. If we don't die.
Call for drinks, okay?
Yes, drinks. Halal drinks.
Halal drinks.
Thank you very much.